Let's discuss the A-level question 2024. Right? Actually, that is the question number 3 appearing in your page number 25. The 2004 A-level question. Right? Let's discuss about this thing. Right? So it says a 10 cubic centimeter sample of effluent water, right, waste water actually, consists of SO3 2 minus and SO4 2 minus ions was reacted with 25 cubic centimeters of a 0.1 molar I2 solution, right? So that is your question. And ultimately they are asking you to calculate the concentrations of sulfite and the sulfate in the effluent water, right? So the goal is to come up with the concentrations of sulfite and the sulfate, right? So let's start with that, right? Identifying the goal. So we can write let, right, the amount of sulfite as X moles and the amount of sulfate, right, as Y moles in 25 cubic centimeters of sample, right? So identifying the goal, right? Then let's try to come up with the chemical equations and the simultaneous equations, right? Okay, the first procedure, it says, right, to 25 cubic centimeters of the sample, right, sorry, to 10 cubic centimeters, no? So this is not the 25, this is about 10 cubic centimeters, no? Right. Okay, they are saying that to 10 cubic centimeter sample solution, right? So that contains the SO3 2 minus ions as well as SO4 2 minus ions, right? Amounts are actually X moles and Y moles, right? To this effluent water sample, right? They have added, to complete react, they have added 0.1 molar I2, right, solution, right, 0.1 molar I2 solution, right? So they have added some I2 solution, right, 0.1 mole, 0.1 mole I2 solution, and actually 25 milliliters of that solution was added, right? Okay, then what are the reactions possible? First of all, what are the reactions possible here? So basically I2, the only possibility for I2 to come up as I minus, right? So I2 and the I minus are the forms available for the iodine as products. X2 form or the X minus form should be present as products, right? So as you are starting with X2 form, definitely it should be the X minus form to come up as a product, right? So this is -1, this is 0. So it is kind of a reduction here, So we are thinking of oxidations occurring at the flask. Right? So when it comes to oxidation states of these guys, sulfur here is with +4 and sulfur here is with +6. As sulfate comes up with its highest oxidation state of sulfur, sulfate can't get oxidized. So the reaction here is actually the reaction between the I2 and the SO32 minus to produce the I minus, and SO32 minus will oxidize to SO42 minus, right? So the reaction here with this flask is actually, right, your SO32 minus reacting with I2, right, reacting with I2 to produce the SO32 minus will oxidize to SO42 minus, and I2 will reduce to I minus, right? This is the reaction there. We need to balance that stuff, right? Okay. After this thing, what they have done, right? So they have taken the solution after this reaction, and they are saying to completely react with the I2 remaining. They are talking about I2 remaining, right? I2 remaining. So that means you have added in excess here. That is why you need to discuss about I2 remaining. If you are discussing about I2 remaining, that means here you have added in excess, right? Okay. So to react with the I2 remaining, they are saying that a Na2S2O3 solution was used. Right? Na2S2O3 solution was used to completely react with the I2 remaining at 0.1 molar solution consumed, right, 30 cubic centimeters, right? So 30 cubic centimeters of 0.1 molar Na2S2O3 was required to completely react with the I2 remaining here after the first reaction, right? That is what it says, right? So let's try to come up with the first simultaneous equation here, right? So before that, let's complete this reaction as well. This is a reaction with the I2 and the sodium sulfate. So it is going to be like this: Na2S2O3. Two of those will react with the remaining I2 remaining, right, to produce 2 of NaI plus Na2S4O6, right? Those are the two reactions here, right? So our data point appears here, right? Our data point appears in this one, and this is our data point, right? This is the data point. So to the number of moles of sodium sulfate, we need to come up with a simultaneous equation, right? First of all, we need to, right, convert these x and y's, right, towards the amount of moles of sodium sulfate, right? So let's try to do that working, right? Before that, we need to come up with the balance ionic reaction for this thing, right? So let's balance the stuff, right? So here this is plus 4, this is plus 6, 2 electron difference. First of all, you need to balance this one. The redox atomic balancing, 2 of iodines, 2D is needed, right? So 0 minus 2, 2 electron difference. So 2 to 2 cancel off, right? So no need to multiply the two halves with any number, right? As the least common factor is 2 and 2 is balanced, right? So then the charge balancing, minus 2 appearing at this side. At this side, it is minus 4, no? It is minus 4 at this side. So minus 2 here and minus 4 here. So we can think of an acidic medium balancing here, right? So that 2 of H pluses are, 2 of H pluses are needed here, and some water molecule here, right? That is how that equation is balanced, right? So as you are starting with x moles here, the consumed amount of I2 is actually x moles. The consumed amount of I2 is actually x moles. X moles is the consumed amount of I2, because 1 to 1, the ratio, it is reacting, right? So this is the consumed. This is I2 consumed, right? I2 consumed is actually x moles, as these are with 1 to 1 ratio. Then what is the remaining amount of I2? What is the remaining amount of I2 then? I2 consumed is x moles to react with the SO32 minus, as those are with 1:1 ratio. So what is the I2 remaining amount then? What is the I2 remaining amount? The I2 remaining amount is actually the amount of I2 added minus the consumed amount. The remaining amount is amount of I2 added minus the consumed amount, right? Okay. So amount of I2 added here is actually 0.1 into 25 into 10 minus 3. I2 added is 0.1 into 25 into 10 minus 3. So the total amount of I2 is that amount, the I2 added. So that is going to be 2.5 into 10 to minus 3. So 2.5 into 10 to power minus 3 is the amount of I2 added, is the amount of I2 added, right? So the remaining amount is going to be that amount minus the reacted amount, that amount minus the reacted amount, right? No, that is the amount of I2 remaining, right? I2 added amount is 2.5 into minus 3, that coming from this. The remaining amount is that minus the consumed amount, right? This is the I2 added. This is I2 reacted. Or the consumed. I2 added or I2 consumed, right? So added amount minus the consumed amount will give you the remaining amount, right? Okay. So the I2 remaining is this amount. So the sodium sulfate should consume is twice of that. As the I2 remaining amount is 2.5 into 10 to power minus 3 minus 6. So in sulfate amount should be twice of that. So we can come up with the equation for sodium sulfate, right? So for moles of Na2S2O3, right? Okay, that amount is equal to 0.1 molar. 30 is consumed. 30 is consumed. The amount is 3 into 10 to power minus 3 moles. So that amount is equal to the I2 remaining amount into 2. This amount into 2, right? Twice of that, right? So we can write 2 into 2.5 into 10 to the power minus 3 minus 6 is equal to 3 into 10 to the power minus 3, right? That is your equation, right? This is your first equation. We can solve that thing here as well. So that is going to be like you have 5 into 10 to the power minus 3. This comes here while this goes here, right? So 2x going to be equal to, right, 2 into 10 to the minus 3. So the x is going to be equal to 1 into 10 to the minus 3. Right? That is right now. So this is 5 into 10 to the minus 3 minus 2x is equal to 3 into 10 to the minus 3. So this comes here, giving you 2 into 10 to the minus 3 is equal to, this comes there, 2x. So x is equal to this value. So x is known. Now we can come up with the concentrate of sulfite, right? Okay, that is the first procedure, right? Let's try to complete the second procedure and come up with the y as well, right? Let's do the stuff. This is actually we are doing the calculation towards coming up with y, right? Okay, what they are saying? They are saying another 10 cubic centimeters of effluent water sample was reacted with 285 cubic centimeters of 0.1 I2, the same thing, right? Acidified with dilyl HNO3 and reacted with excess BaCl2, right? So what they have done? So they have done the procedure again they have done the same procedure again, right? It was like you had SO32 minus and SO42 minus. Again, they have taken 285 cubic centimeters, right? That means same X moles as well as Y moles appears here, right? Again, the same amount of I2 is added as the earlier case, right? That means another excess amount, 0.1 mole at 25 cubic centimeters were added, right? So again, we definitely know the I2 will get reduced to I minus here, so that as this is a reduction, we are looking for some oxidations here. So sulfite will also oxidize to sulfates here. Sulfite will also oxidize to sulfate. No? So with that, we'll come up with this kind of solution, right? Sorry, write that thing. This kind of solution, we have only the sulfate ions are remaining, right? Then the equation here is again the same equation like this. So H2O reacting with SO32 minus, right, plus I2 producing the SO42 minus 2 of I minus plus 2 of H plus, right? So the amount of sulfate here is what? How much the amount of sulfate there? So here we have started with X moles. That X moles was totally converted to sulfate here. So from sulfides, you got X moles of sulfate and right, the unreacted sulfate is still there. As this one is not reacted, that Y value is still there, right? That Y value is still there. So earlier you had sulfite amount, right, which is not reacting with I2. There was sulfite, so sulfate, right, not reacted, is also appearing as sulfate still. That was the Y amount. So total moles of sulfate at this flask is X plus Y now, right? X plus Y moles, right? To that solution, they have added some barium chloride. They added some barium chloride. To this solution, they added some, right, excess of barium chloride, right, with some HNO3, some HNO3. So we know definitely these ions won't participate in any kind of precipitation, nitrate ions as well as H plus ions, right? So only ion we have to consider here is the barium 2 plus ions, because you don't have a positive cation to consider the Cl minus here, right? So the precipitate, the only possible precipitate here, it won't dissolve in nil acid C1, is the barium sulfate, right? That mass is given as 0.932 grams, right? 932 grams. So what is that precipitate? Definitely it is going to be the barium sulfate, that is barium sulfate, right? Okay, we can write that equation there. So barium chloride reacting with the sulfate ions at the flask to come up with the barium sulfate precipitate and the 2 of Cl minus ions, right? As you are with X plus Y moles of sulfate here, the amount of barium sulfate precipitate should be also X plus Y, as those are with 1:1 ratio, right? So now we can come up with the second simultaneous equation for the mass of the precipitate. Mass of the precipitate, right? Here is your right second data point. Right? Let's come up with the equation for that, right? For the mass of the precipitate, right? For mass of barium sulfate precipitate here, right? In grams we are concerning. So for first of all, we need to come up with the molecular weight of the barium sulfate, G mole minus 1 value, to convert this X plus Y into grams, right? So molecular weight of barium sulfate is actually barium is 137, sulfur is 32, and the 4 of oxygens means 16 into 4. That summation will give you 233 G mole minus 1. So the mass of barium sulfate is going to be the G mole minus 1 value into number of moles, right? Moles value. So that is going to be 233 G mole minus 1 into X plus Y moles. Right? That value is equal to the precipitate mass 0.932, right? So you can simplify this thing, right, by dividing by 233. So that will give you X plus Y as, right, you have 4 of these things, no? So 0.004, 0.004. That means 4 into 10 to the power minus 3. 4 into 10 to the power minus 3. That is your second simultaneous equation, right? So now you had obtained two simultaneous equations, right? Your x value is 1 into 10 to the power minus 3. X plus y is 4 into 10 to the power minus 3. So that we can solve these two, right, to come up with the x and y, right? I'll erase this thing. Right? From 1, x is equal to 1 into 10 minus 3 moles. So substituting that value to 2, you will get the y as, right, 3 into 10 minus 3. Right? So x and y has been solved. Right? So now we can come up with the concentrations of the sulfite and the sulfates. Right? So the concentration of sulfite, first of all, no? Sulfite ions, right, that is going to be equal to number of moles of sulfite, that is x moles, 1 into 10 to the power minus 3, divided by the volume of the solution, that is 10 cubic centimeters. The x moles were inside 10 cubic centimeters, right? Okay, sorry, here the value is 10 cubic centimeters, right? Sorry for that, right? It was inside 10 cubic centimeters. The earlier solution was taken, no? The same solution, yeah. Okay, so the value here is then going to be, these two will cancel off to give you some 0.1 as the concentration. What about the other stuff? The sulfate and concentration. So the number of moles of sulfate is y moles, that is 3 into 10 minus 3. The volume there, that goes inside actually 10 cubic centimeters, right? 10 cubic centimeters, right? Okay. So 10 into 10 to the power minus 3 decimeter cubes. So the value is going to be 0.3. So those are the two values, the two concentrations of sulfite and sulfate ions in this effluent water, right? So this is the working for the A-level question of 2004, right? Let's complete the stuff.